Okay, so to have a read of this question. A golfer hits a ball from point 0 on horizontal ground with a velocity of 50 meters per second at an angle 25 degrees above the horizontal. So, do a little sketch. That's 50 meters per second. That's going to be 25 degrees above the horizontal. And we know it's going to do something like that, and it's going to land at a point A that's on the ground. Let's just do our first little bits here. We know that's 50 sine 25, and resolving horizontally, that's 50 cos 25. Now, because it's related to hitting the ground, we're going to resolve vertically. And here we have S. It's going to write D for the displacement. That equals 0. Now we have U resolving vertically equals 50 sine 25. And we're looking for the time taken. So we're going to have a T equals question mark. Then we've got SU and T, and if we resolve up or down, we have acceleration that acts downwards, which is minus 9.8. So what letters have A, S, T and U? What's that formula? It's going to be this one here. So we just use S equals UT plus a half AT squared. Let's just write that down as good methodology. Now we know S equals 0. Now be careful, because sometimes when I'm just working I use that S as a 5 and totally go down the wrong path. So let's just substitute these values in. Sine 25 T plus a half AT. Now A is minus 9.8, so I can just jump to minus 4.9 T squared. Because we have T's on both terms, I'm just going to take T out and make that 50 sine 25 minus 4.9 T. Now we know all that equals 0. So we know one solution is T equals 0, that makes perfect sense. And then this bracket here must equal 0. So we're just going to solve 4.9 T equals 50 sine 25, because we want this to be 0. So T is just going to equal 50 sine 25 divided by 4.9. So T is going to equal 4.31 seconds. And that's a quite nice one. Now that is part 1. Part 2, the distance OA will resolve horizontally there. We have U equals 50 cos 25. I want you to always just do this out of habit. A equals 0 here. Just going to change colour pen and segment that bit out. Now we know T from before, because it hits the point A. It hits the point A at T equals 4.31 seconds. So we can still use S equals UT plus a half AT squared. Now A equals 0, so S does just equal UT, and you just multiply your U and your T together. So S, which is displacement, equals 50 cos 25 times 4.31, which we should get an answer of 195 meters. So S equals 195 meters, and that's quite easily done. I've started off this question with a lot of the solution, and I'm going to show you how I got there, because this might be easier for me to talk through. So you've got a small ball, it's projected at an angle of 50 degrees above the horizontal from a point A, which is 2 meters above ground level. These are your key words. The highest point of the path of the ball is 15 meters above the ground, which is horizontal. So the ball is 15 meters above the ground and it's at its highest point. Well, we should know from our earlier knowledge of mechanics that means V equals 0. Velocity equals 0 when it's about to turn. Now in this context, S equals 15 to start off with, and well, U, we're looking for U, so we call U as U. Now the speed, we need to find the speed with which the ball is projected from point A. And you can see this diagram. Here we've got the angle 50, this is A, but it's 2 meters above the ground already. So actually in this question, S equals 13, because 15 minus the 2 gives us that height of 13. Now we've got 50 here, the angle 50, and we've got U. So we always start with U sine 50, and that's not U sine 50, that should be U cos 50, but I think this is a part of this section here. So let's do a pen and write horizontally, though we might not need it, but that's U cos 50. Now let's go back to the highlighter. So we've got V equals 0, we're looking for U, and we resolve vertically because of the height is 13, and then that makes us A equals minus 9.8 because that's acting downwards. So remember, we're resolving upwards as well. So what SUVAT formulas can we use? This is this V squared equals U squared plus 2AS. So step 1, let's just write that down. Now this can easily happen, so I've left it up here to show you this is what I wrote initially. It's U sine the angle, so I need to rub that out. And these things can easily happen to all of us. You may have seen it yourself when you're just doing questions, you've done everything perfect, and you've just done something wrong by just writing a number and substituting it in incorrectly somewhere, and it messes up your solution. So once we have this is going to give us minus 19.6, so we're going to bring it over the other side. So we're going to get 19.6 times 13 equals U squared times sine squared 50. Why is that? Because we're substituting U squared here, and in this question that's why I've got this here, U equals U sine 50. So we've got to next step is going to be 19.6 times 13 divided by sine squared 50 equals U squared, and plug that into a calculator, and that's going to equal, once you square root it, U is going to equal 20.8 meters per second. Now be careful on your calculator to just do sine 50. Once you get the answer, square it, because you could make a mistake with that and mess up your final answer mark. So a ball hits a net at point B here at a distance of 45 meters. So in context of this question, let's just assume that's here. Now can we see we're resolving horizontally? So and we will resolve horizontally. A equals 0 because A is only acting downwards. Now it says find the height of B above the ground. Well, we have S equals 45 first. Now we need to resolve horizontally and then vertically to solve this. It's a 6-mark question. So we can use S equals ut plus a half at squared because a equals 0. So we have S equals ut. Now in this question, horizontally is u cos 50. So I'm just going to call it uv cos 50. I mean uv equals cos 50 times our original u, which was 20.8 here. So that uv equals 20.8 times cos 50. Let's just write that a bit clearer. Now I should have probably did that in my last question before, because you can't have u and u in the same equation like this, because that actually doesn't make sense. So S in this question equals S equals UVT, but we know what U is. UV is this, so we get S equals 20.8 times cos 50 times T. Now S equals 45, so we get 45 is going to equal. Now do use your fraction button on the calculator when you do this, because the calculator uses BIDMAS rules, so that's going to equal T. Now we're going to get, when you use that on your calculator, T equals 3.36 seconds. Now when you've got this 3.3 seconds, we can now resolve horizontally. Now just in case you're wondering, if you use this on your calculator you get 3.37 seconds, is if you use the actual accurate value of u, not rounded up, you will get 3.36 seconds. But the mark scheme should allow you to use 3 significant figures. Right, so resolving upwards. Now if we resolve upwards now and we use t equals 3.3 seconds, we will be able to find our height of the net using t equals 3.3 seconds. So we're resolving upwards. We've got a equals minus 9.8. We've got u sine 50 still, so I'm just going to use uv equals 20.8 sine 50. Alright, so what are we going to use? Because we need the height. So once again we must use S equals ut plus a half at squared. So we're going to get S equals 20.8 sine 50 times t, which is 3.36, minus, well really it's plus 0.5 times minus 9.8 times 3.36 all squared. Now if we plug that into the calculator, what do we get? We get S, I was going to say it's SD equals minus 1.78. Now that's in meters. Now in the context of the question, I hope you can see here, A is 2 meters, so the net will be minus 1.78 from here. So the height of the net must be 2 minus 1.78 meters, which equals 0.22 meters. Now your answers will vary subject to how much you rounded, but that should get you all the method marks and answer marks. If you want to be more accurate, do use the answer key in your calculator. Hopefully that makes sense. Now part 3 is a skill you might not remember, so let's do this in red. Now it says find the speed of the ball immediately before it hits the net. So in the last question at 45 meters, which we're just going to say is here 45 meters, it's asking what the speed is as the ball travels down here as it's about to hit the net. Now if you think about it, if we can get the vertical speed and the horizontal speed, we can use Pythagoras Theorem. Perhaps like this will be easier to get that speed. So if we resolve horizontally, well, the horizontal speed u cos 50 is constant. That's resolving horizontally because it's not affected by the gravity as such. But v, we're going to call that v, and that's the vertical speed. That's affected by gravity, and that can change because, for example, v here is 0, isn't it? So that means it can change. So if we're going to use, let's just call it VV, we know using V equals U plus so VV is going to equal the vertical V, which is, you can see, V sine 50. We're just calling it V sine 50 here. V sine 50 minus 9.8 times t. Yeah, because that's resolving vertically. And we are using V equals U plus AT essentially, to solve that equation. But remember, A equals minus 9.8 here, so that's how we get that. So plug that into the calculator using this V here from your original question from book part 2 or part 1. That's 20.8. So let's plug that into the calculator and see what we get. And just so you're not sure, so this V here, or we could say it's here, is going to be our speed from before, the initial speed, 20.8 times sine 50 minus 9.8 times our t from the original question before, which is 3.3 seconds times 3.36. So we get V equals minus 16.994 and so forth, and then we're just going to round that to minus 17, which would make sense because it's going downwards with gravity. So at that point, when it hits a net, V is going to be minus 17. And if you change it to the positive direction, it's going to be 17 meters per second. And remember from before, we know the horizontal is what we have are U cos 50, so that's 20.8 times cos 50. That's our U from part 1 here. Now I know we could get in the bits of the u's and v's mixed up, but bear with me. So that's 20.8. So can you imagine this triangle? That way. That's 20.8 times cos 50, and we've got our down speed as it's about to hit the net as 17 or minus 17 or 17. That's going to be the same this side really. So if we use Pythagoras Theorem, we just need to do, and it doesn't matter if we use minus 17 squared, we need to use 17 squared plus 20.8 cos 50 all squared, and we're going to square root that to get VV, the final V, or V final, just so we don't get mixed up from before, and then we'll get V to equal 21.6 meters per second. So I hope that makes sense, but that could be a little tricky for you to understand.